Hello everyone, this is lesson 16, the final lesson for Arduino and C. In this lesson, first we will talk about unions. Unions allow you to have a variable take on different data types. So the format for unions is union, and then the variable list, and then down here a variable name. An example is union, let's say a float for analog input. So analog can be a decimal point, has a decimal point, and then digital input, which is either 0 or 1. And lastly, let's give this a variable name. Let's say sensor input. So this is an example of union, but in here, let's use another example. For example, union, let's say integer x and float y. So we can give the integer x a value or integer y a value. The union can only have one value at a time, and if it has two, then it overrides the one previously. So for example, we can say, give this my union. So let's say my union dot x, so this variable here, equals 3. And then we can print this, and this should be 3. Semicolon here. And it prints a 3. But if we add a float after this, let's say this equals 0.4, then the x gets overridden by the 0.4, and although if we write print x, it wouldn't say that it's wrong. It can still print, but the value is not correct anymore. It would print out a negative 13,107. So this is because they're written into the same byte, and the data for x equals 3 is overridden by y equals 0.5. And so the value for the union my union would be 0.4. But then this line tells us to look at the part where it stored x previously and look at what the value is. So then it found it's negative 1,300 or 13,107. So yeah, this is unions. It can only store one value at a time and overrides the last one if a new one is needed. Alright. After unions, we have libraries. So we talked about this earlier in the first few videos, that for this lesson, libraries allow you to bundle related functions into a single file that the Arduino IDE can compile into your sketch. Instead of having to rewrite the functions in your code, you just reference the library file from your code, and all the library functions become available. This is handy for Arduino shields. So what this means is that libraries have predefined functions that we can just reference or call, and it can instantly be run on our code. So how to define the function? We do hashtag include, and then these brackets, and then the library name. An example, say defining the library in your sketch, and then example would be hashtag include eeprom.h. And eeprom is something that we'll talk about later on in this video, but just know that this is a library that is very important. And then referencing the library functions would be library name dot function. Library dot function. Example would be eeprom dot read, and then a location 0. We'll talk about this one later. And then installing your library would be, there's 3 possible ways. I will only list one here, and that is to open the Arduino IDE, select the sketch from the menu bar, select import libraries from the submenu, select add library from the list of menu options. So here we go to sketch, include library, add a zip like that. And another way is to go to the library manager here and search up whatever you want. For example, eeprom. Yeah, like that. And the third option is to manually do it. I covered this before, so I won't go through it again. But yeah, this is libraries. And after this, let's talk about eeprom. So this is the thing I was talking about here. EEPROM is the long-term memory in the Arduino. It keeps data stored even when powered off, kind of like a USB flash drive. So even when the Arduino Uno board is not plugged in, the EEPROM still has memory stored in it. And this is a very important note. The EEPROM becomes unreliable after 100,000 writes. So it doesn't really matter how many times you read the memory, but if you write into it more than 100,000 times, then it becomes quite unreliable. And you'll need to include the library file in your sketch. After you include the standard EEPROM library file, you can use the 2 standard EEPROM functions in your code. So there are only 2 standard EEPROM functions. One of them is read, and then address. So to read the data value stored at the EEPROM location specified by address is using eeprom.read. And the other one is eeprom.write. So this needs both an address and a value to write into the location. So to read values to the EEPROM location specified by address. Alright, so for the EEPROM, this is a default library or basic library, and it should be included as a default library here. And because of that, Arduino by itself in the examples provides a lot of examples for EEPROM. For example, the clear, CRC, get, iteration, put, read, update, and write. But of course we don't have to use the functions in there. We can write our own. For example, I am going to write a small code that writes stuff into the first 255 or 256 locations and just write the number into it. Example, for integer I equals 0, I is less than 255, I iterate, and then we can write EEPROM.write in location I, write down I. So now this is a number I, and then we can print it out. Serial.println location, and then the location, and then we can print out the value, and then we can print out EEPROM.read. We can read the address at I, and no need to make these print lines. Alright, and don't forget to include the library. I forgot to include it myself. Include EEPROM.h. And when we're writing includes, we don't need the semicolon at the end. Oh, forgot the here. Alright, so now we are writing the values into the EEPROM on our Arduino Uno board, and then we can read it out. So if we go to examples, EEPROM, and then read, for example, then I'll explain this code. First, we include the EEPROM library into our sketch, and then we give an integer for address. The address is where we want to put down the value, and then the byte value would be a byte, which is 0 to 255, and then the void setup, it begins, and this is trying to connect to the serial monitor. And next, in the loop, which loops indefinitely, it first reads the address, and then prints the address, a tab, and then this is the value, and then in decimal, and then we print out a line, and then here we add 1 to address, and then if address is the length of EEPROM, that means we got to the end of the EEPROM memory length. Then we start at the beginning again, and then restart. The delay means it pauses for 0.5 seconds in between. This is a very good practice, and I probably should have included it into my code, and I didn't because I wanted to save some time, and that's a very bad practice. Don't copy me. And over here it says the Arduino Uno has 1 kilobyte of EEPROM storage. So 1K, which is 2 to the power of 10 bytes. so I should probably include this. The EEPROM for Arduino Uno has 1 kilobyte of memory. And if you want to look at like the Mega, then it has 4 kilobytes, and it's different for each board. Alright, now we can read this, so let's run it. And then let's look at the board. So here, 0, 1, 2, 3. So now it's successfully reading what we have on the board. But we only wrote to 255. So let's wait a while and see what happens after that. Would it stay at 0 or something else? So now, as you can see, it pauses 0.5 seconds in between instead of what I wrote, which is one line right after the other. Pausing is substantially better because it won't make the EEPROM overheat. So now it's at 80. Okay, wow, this is kind of slow. Alright, I'll assign the homework while this runs. So, homework. So for homework, let's do something a little bit challenging. Let's write in the EEPROM the location from 0 to 100, where the value is counting down from 100 to 0. So example is location at 0, the value is 100. And then if the location is at 1, then the value is at 99. And then location at 2, the value would be 98, and so on, and so on, until we get to location 100, where the value would be 0. And then since this is kind of challenging, I will give a hint. So the hint is use a for loop and make it EEPROM.write. The address is I, while the value equals 100 minus I. So at location 0 is 100 minus 0, which would be 100. 100 minus 1 would be 99. 100 minus 2 would be 98, and so on. This is a little more challenging, so try to complete it. Alright, let's come back to our code. Now it's at more than 255, and we'll notice that every single line is now 255. And that must mean everything is full, because 1 byte, the maximum number that can be represented, is 255. So that means, since I haven't tampered with these ones yet, that means at the start every single byte is 255. Alright, that's it for this video. Thank you for watching.